Hello students, this is Indrani ma'am from Rasayan. In this lecture, I am going to explain how to find out the products of oxidative cleavage by periodic acid. Now first you should know what is periodic acid. HiO4 is periodic acid. What is the oxidation state of iodine here? Each oxygen is having oxidation state -2. So -2 into 4 means -8. Hydrogen is having +1. So if you put oxidation state of iodine is X, you will get oxidation state is +7. So iodine is in its highest oxidation state in HiO4. So it is strong oxidizing agent. It oxidizes others and itself it will be reduced. Now see, HiO4 oxidizes vicinal diol. Vicinal diol means 1,2-diol. Means with respect to this OH, if this carbon is 1, then next carbon is 2. At that carbon also one OH group is there. So two adjacent carbon atom, if they are containing OH groups, it is called vicinal diol or 1,2-diol. So HiO4 cleaves oxidatively this bond. So oxidative cleavage takes place here. Oxidative cleavage means breaking of bond and oxidation takes place. Another point you have to remember, cis diol means OH groups are at the same side as it is here, oxidizes more rapidly than trans diol. Why it is like that? Then you should know little bit about mechanism. Mechanism is not that much important, but actually what is happening here? This is vicinal diol plus we are treating it with periodic acid. This is the structure of periodic acid. So during the reaction what will happen? Removal of water takes place. 2 H and 1 O will go and you will get, first you will get one cyclic intermediate. Then O3H. This is called cyclic intermediate. Now see, if two OH groups are not cis, if they are not at the same side, then it will be difficult to generate this cyclic intermediate. That's why cis diol oxidizes more rapidly than trans diol. After that what will happen? This bond will cleave, it will cleave and it will cleave. Product will be from this side we will get CO plus from this side we will get this CO plus iodic acid HiO3. Now what is the oxidation state of iodine here? This is iodic acid. Each oxygen is having -2, so -2 into 3 means -6 plus 1. So this is +5, because +5 plus 1 means +6 and -6, total should be 0. Here it is +7, so reduction is taking place here and it is oxidizing this vicinal diol. This is called Malaprade oxidation. Similar type of oxidative cleavage also takes place with lead tetraacetate. Lead means PbOAc whole 4. This is called lead tetraacetate. So we have seen periodic acid oxidizes vicinal diol. Also it can oxidize alpha hydroxy carbonyl compound. It can oxidize alpha dicarbonyl compound and it can oxidize alpha hydroxy acid. So for such type of moieties oxidative cleavage takes place. One by one we will see all the examples. Now see, this is glycol. It is having 1,2-diol or vicinal diol. So if you treat it with periodic acid, how you will get product? What you have to do? Just cleave this carbon-carbon bond and on each side with the carbon add OH. Here you add OH, here also with this carbon add OH. So what you will get? So this bond is now not there. In place of that, we are having CH2 with this carbon. Already one OH is there and another OH you have to add. Plus here also same thing, CH2 with this carbon, already one OH is there and another OH we have to attach. We know with the same carbon two OH groups are not stable. So what will happen? Removal of water takes place. And from here we will get formaldehyde. From here also we will get formaldehyde. So these are the product of pyridic acid oxidation, two molecules of formaldehyde. What is it? This is the structure, formaldehyde. So two molecules formaldehyde we are getting. Next example. Now for this compound, what is the pyridic acid oxidation product? First you have to check whether in your compound any of these moieties is present or not. So here vicinal diol is there. So you have to break this bond and on each side with the carbon add OH. So here what will happen? With this carbon 2 OH will be attached. So after removal of water, here we will get CH3 CHO, acetaldehyde. Now what will happen here? Plus, first you have to practice like this way. With this carbon 2 CH3s are there and 2 OH are there. With the same carbon 2 OH not stable. So remove this H and this OH. So what will happen? By removal of water from here, you will get CH3 C double bond O CH3. So what are the product? Acetone and acetaldehyde. Now see next molecule. If you treat it with pyridic acid, whether it will react or not. First you have to check all those four types of systems. So here vicinal OH groups are there, here. At two places vicinal OH groups are there. This is methyl glycoside. This is monosaccharide, and methyl glycoside means closed chain structure you have to consider, and ether linkage. This is ether linkage. It is stable by pyridic acid oxidation. So here cleavage takes place and here vicinal diol is there. So here cleavage takes place. So at either side here, at each side here add OH, and here also at each side add OH. So what are the products? This carbon no cleavage because here that system is not present. After that with this carbon CH, two OHs are there, removal of one water will give here CHO, aldehyde. Then this part as it is, write this part as it is. Then here, see this moiety you have to write, then CH2OH. Here no such type of systems, no vicinal OH is there. So you have to keep this one as it is. Here with this carbon already one OH is there, another OH is there. So by removal of water here you will get CHO. And here what will happen? With this carbon, see one OH is there, and from here we are getting one OH and from here we are getting one OH. So at each side OH. So with the same carbon 3 OHs are there. So what you have to do? From any two OH remove water, OH and H. Then by removal of water what will happen here? You will get HC double bonded O, here OH. So formic acid. So we are getting this and this product. This is next compound. Now see two carbonyl groups are there and we have seen alpha dicarbonyl compound gives pyridic acid oxidation product. So with respect to this carbonyl, next carbon is alpha and this carbon is beta. And with respect to this carbon is alpha, this carbon is beta. So this is nothing but beta dicarbonyl. It is not alpha dicarbonyl. So there is no reaction. Now see, for this compound CO group is there and OH group is there. So with respect to this CO group, this carbon is alpha. So this is nothing but alpha hydroxy ketone, means alpha hydroxy carbonyl. So this will give bond cleavage by this reagent. So how you have to write the product? This carbon-carbon bond, where at one side OH group is there and another side C double bond O is there, cleave that bond. With this carbon add one OH, with this carbon add one OH. So what will be the product? See here, CH3, CH, here already one OH is attached, attach another OH, plus here CH3, CH2, C double bond O, with this carbon attach OH. So with one carbon, two OH not stable. So removal of water will take place. From here H and from here OH will go, and by removal of water we will get here CH3, CH double bonded O, means acetaldehyde. This is one product and this is another product, this acid. Next, find out the product for this reaction. So see, with respect to this carbon is alpha. With respect to this carbon is alpha. So this is nothing but alpha dicarbonyl compound. This compound alpha dicarbonyl. So it will give periodic acid oxidation bond cleavage. So what you have to do, break this bond. With this carbon add one OH. Here with this carbon add one OH. So what will be the product? R1 C double bond O OH plus R2 C double bond O OH. So these two carboxylic acids we are getting. Now here with respect to this carbon is alpha, this carbon is beta. So this is beta hydroxy carbonyl with periodic acid oxidation. Alpha hydroxy carbonyl gives product, but here there is no reaction. This is also vicinal diol system. So break this bond. Here with this carbon add one OH, with this carbon add one OH. Since in this carbon two OH groups are attached, here also same thing. So removal of water will give one CHO group. So here how many CH2s are there? 4 CH2 groups are there. We can write like this: CH2, 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 here one CHO. After removal of water, here one CHO, dialdehyde we are getting. So in this compound, by periodic acid oxidation, how many molecules of periodic acid will be consumed? Here vicinal diol system is there. So here one molecule of periodic acid will be consumed. Add one OH, here one OH, and here vicinal diol system is there. So here one molecule will be absorbed. So total 2 molecules of periodic acid will be consumed. So with the same carbon 2 OH groups are there. By removal of water, here we will get aldehyde. From here also we will get aldehyde. So 2 molecules of this are CHO, and here with this carbon 3 OH groups are attached. So here by removal of water we will get formic acid. So these are the product here. See, this is not vicinal diol system, this is ether. So there is no reaction with periodic acid oxidation. This is cyclohexane 1,2-diol. So vicinal diol is there. So it will give periodic acid oxidation product. Now see here, both the OH groups are here above the plane, means at the same side. Cis, here both the OH groups are below the plane, means at the same side. So here formation of cyclic intermediate by HiO4 takes place, and it is very easy. So oxidative cleavage takes place here and we will get the product. But if the structure is like this, one OH is above the plane and another OH is below the plane. What will happen then? The reaction will take place or not? Here also reaction takes place. Why? Because you have to draw the chair conformation. In the chair conformation, suppose this carbon is 1, this carbon is 2. So here this is 1, carbon 1 and this is carbon 2 suppose. So here OH is above the plane, means above the plane OH, and here OH is below the plane. Below the plane means here we can write like this. Now see, this is axial position, this is also axial position. So this is axial conformation. 1 to diaxial, this is trans, this is above the plane, this is below the plane. Trans. Here no bulky groups like tertiary butyl group is present. If no bulky groups present, then ring flip takes place. So by ring flip, what you will get? This carbon will come here. So this is number 1 carbon and this is number 2 carbon. So by ring flipping, this is above the plane. Here also it will be above the plane, but axial will become equatorial. And here also this is below the plane. Here this is below the plane. This is also equatorial. So here this is di-equatorial conformation. So see here, formation of cyclic intermediate by HiO4 is difficult, but here two OH groups are closer to each other. So here formation of cyclic intermediate takes place because ring flipping takes place in absence of any bulkier group in cyclohexane ring. So due to this conformation, cleavage takes place here and we will get the same product here for this and this. Now see whether periodic acid oxidation takes place for this compound and this compound. What is the difference? Two OH groups are at the same side. Here two OH groups are at the different side, but here carbon-carbon single bond is present. So here periodic acid oxidation will take place for both the compounds, whether OHs are at the same side or whether OHs are at different sides. Rate of oxidation here is faster than this, but reaction takes place. In this video till this, if you like, please subscribe. Thank you for watching.